There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest on this episode of Blue Blazes is John Waters, a seasoned technology leader, accomplished architect, and my fellow partner at Trailhead. With decades of experience in software architecture and a career spanning both the US and Sweden, John's delivered innovative solutions for many industries, including public transit, finance, and healthcare. In this episode, John and I dive into the exciting new features of .NET 9 and see how they empower developers to build modern, high-performance, scalable applications. Drawing on his experience, John highlights the most impactful updates from this latest release, and I'm thrilled to share the conversation with you. Hey, John, thanks for joining me.
EJ.
Great to have a fellow Trailhead person on the podcast for the first time. So welcome to Blue Blazes. Now, as you know, .NET 9 just came out recently, and Trailhead, we're a big .NET shop. So what are you most excited about at a high level with .NET 9?
There's a lot in there. I recently watched the .NET Conf event at 2x speed, and even with that, there's a lot to consume. And even outside of .NET 9, there's so much more that's kind of released in the same ecosystem, the tooling, SDKs, and GitHub Copilot, and all these different libraries for different specific things like ASP.NET and Blazor. And it's just this huge dump of things that Microsoft has been working on for a year. But I think what they're definitely focusing on a lot in what they think is important is .NET Aspire has had a huge presence in .NET 9. AI, that's another big focus for everyone. Performance is always something that's kind of worked into each new release, and they're relentless on adding performance at every level. And then it's a kind of a sprinkling of other things that are interesting, ranging from JSON improvements to little things like the hybrid cache and little things that might be useful for you. But I'd say, .NET Aspire, AI, and performance.
I saw a video online that counted the number of times they said .NET Aspire in the keynote, and I think they might have said it more than the.
Sounds like it could be a drinking game.
It does sound like. Jay here. Just a quick break in the conversation to share how Trailhead can help you tackle your toughest business challenges. When you're navigating uncharted technology terrain, Trailhead creates custom software solutions that put you back on the path to success. Ready for the next step? Get started with an expert consultation at trailheadtechnology.com/offer. That's trailheadtechnology.com/offer. Now back to the conversation.
.NET Aspire.
You also mentioned performance, which I think is a great one to talk about here because .NET 9. We'll talk about this maybe in a minute, but it's a standard term support release of .NET, which sometimes can mean that there's not as much like wildly new stuff. It's more support types of things, including performance. But what's really exciting to me as a .NET developer for 20 plus years is that in the old days, performance was not a major concern in .NET Framework. And since .NET Core and now modern .NET, it seems like every version just gets wildly faster than the last. What have you noticed around performance that is exciting to you?
Yeah, there's just been a lot of changes, and there's some very detailed information about what all the changes are. And some of them are very nitty-gritty things, and some of them are easier to grok what they mean. I saw a statistic that there are 1,000 pull requests related to performance improvements in .NET 9. and they range from like really smart things in the just-in-time compiler that will benefit everyone to like server garbage collection that may be specifically better in a kind of multi-core environment, so more specialized. But there are lots of things in there that do affect kind of general business applications and not just kind of library and toolkit makers. Minimal API, I think, has gotten a lot of benefits out of the performance improvements, specifically lower memory usage and higher throughput. And a lot of that has to do with just JSON serialization, deserialization improvements. There's been a lot of work in the JSON space, also related to things around Open API and kind of generating documentation as well. Benefits from the JSON work. There's been a lot of work on native AOT, which I think is a push, has been a push for quite a while now to add AOT ahead of time compilation support, which really benefits apps because then not only do they start faster, they use less memory. You can strip out a lot of things that are not actually needed. You can include kind of everything in one executable. But all kinds of patterns that rely heavily on reflection don't work very well with ahead of time compilation because the things they want to reflect on tend to get stripped out because the analyzers can't see that they're being used.
Right.
And so things like serialization is an example of where AOT support is important and where you can do things like generate things at build time, either with source generators or other tricks to kind of move that stuff that would be happening at runtime into build time.
Mm-hmm.
So there's a lot of performance that can be gained that way. And then really anytime you're working at a high level with Microsoft .NET classes, you can benefit from a lot of improvements that happen under the hood. So if you're working with generic things like dictionaries and lists and not trying to get too into the details of the implementations yourself, then when a new version comes out, they might have maybe internally switched to using spans, which has been also another theme that they've been working through everything, trying to use spans as much as possible to really minimize memory allocation. And so now they've got some new cool methods like alternate lookup inside of things like dictionaries that allow span-based logic to be much more efficient. So if you're working on that higher level, you get those benefits of those performance improvements that have happened kind of inside the framework classes automatically in your apps.
Mm-hmm.
Also some just great productivity performance improvements, like Link has gotten some nice new additions for the kinds of operations you need to do to group and count things. So now there's, instead of having to create this syntax for grouping and counting that you never remember, there's some count by and aggregate by helper methods that do it kind of with less code. And then just throughout the rest of the stack, there's been improvements for specific technologies like SignalR has better compression, which benefits Blazor. There's Blazor also benefits from pre-compiling assets, kind of like in the Blazor world, all of your images and script and stuff can now be minimized and fingerprinted and distributed just like you would with Webpack with web development. So it's just
So
kind of
it'd be better for versioning as well, right? You don't have to worry about caching, over
the
caching
browser
things.
can cache it safely. That's right. So
Mm-hmm.
so that's just across the board all of these different improvements, and some of them you don't really have to do anything other than upgrade if you've been working at the higher abstraction level, and also if you've been working at that level with maybe cloud deployment rather than on-premise, you tend to get those improvements like server garbage collection and so on if you're running an app service, because you're not micromanaging all those details about how it's hosted anymore. So the higher abstraction level you're at, I think the more of these automatic benefits you're going to get.
Yeah, you remind me of I think an important point, which is I mentioned earlier, .NET 9 is a standard term support. So for those that don't know, I know you know, John, but for those that don't know, Microsoft does this sort of TikTok release pattern with .NET where there's a standard term support 1 year, and then the next year is a long-term support, and I believe that's 18-month support for the standard term and
36. Yep.
36 for the
Yep.
long term. And it's sort of started creating this pattern in the .NET community where people don't bother to update to the standard term support. They just wait a year. Now there may be good reasons for that at times, but uh, you know, I'm interested in your thoughts about why you might consider doing a standard term support version of .NET like .NET 9 is as an upgrade,
Yeah.
particularly if you're on a more recent version of .NET 6, 7, 8.
Yeah, it reminds me a bit of hopscotch.
Yeah, that's right. That's right.
It's an interesting concept, and it's kind of mirrored throughout the ecosystem, but some things move a little faster than that. Like Aspire actually moves faster when they want to
Mm-hmm.
kind of break things and move along faster.
Mm-hmm.
I think to me it depends kind of on what your if you're going to do ongoing development, if your product just is going to have kind of continuous improvement, then it makes sense to just always upgrade to the latest .NET version pretty soon after it comes out, obviously in its own branch, and you're going to have to regression test some things, but just updating the SDK and version numbers kind of gives you a lot of benefits right out the bat. And then you want to look at, well, what's new? What are the things that I specifically need to change some code to take advantage of, like the hybrid cache. But if you're kind of planning on continuous improvement, then there's no reason to hold back. If you are more of like I'm developing this system and I'm going to launch it, and then we're not really going to have any planned maintenance on it for a long time, it might make sense to pause on the long-term support version until it's time to start developing again, and then more about should I just jump to the current STS or should I
Yeah.
stay on where I was at. So it kind of is coupled to your life cycle. Um, we do see clients that tend to get stuck if they don't keep up. Like they'll be like, oh, well, I'm going to skip this one. There's nothing really new about it. And then they get one version behind and they get two versions behind. And at some point, the technical debt starts to grow and there's breaking changes and it becomes an impedance. And you feel like, well, now it's a big deal. And now I'm going to estimate the cost for this new feature that my customers want. But now I also have to add all of this cost for you know, updating things and really adding no functionality that's going to be a
Mm-hmm.
significant amount of my budget. And it's hard to motivate that. So then they still don't upgrade. And then you get stuck behind something that's really changed a lot, like when .NET Core went from 2.1, I think, and Entity Framework changed a bunch how it worked, and
Yeah.
people just got stuck. So I think you want to have this continuous improvement. It's a healthy thing to do. It's just like refactoring your code. Um, you want to do it frequently enough that it's not really a big deal.
Mm-hmm.
And you don't have to budget extra time for it, and you don't have to ask for permission to do it.
Yeah.
It's just built into your software development, is keeping things up to date.
So what I
Um,
hear you saying, if I can paraphrase, is that not only do you get those performance improvements that we were just talking about, for free essentially if you upgrade to .NET 9, but it also puts you in striking distance of any minor breaking changes that you might have to worry about when .NET 10 comes out in the future and you want to upgrade to that. Now you're closer to that than you were before, right?
I think I listened to one of your previous podcasts. I think it was on the topic of DevOps, where the the thing was, if it's painful, you should do it more often.
Yeah, good advice.
Another aspect of this keeping up to date is security. Um, I saw somewhere that 90% of the code that you ship is someone else's code.
Mm,
It's someone else's NuGet packages. And of course, those NuGet packages rely on other people's NuGet packages, and there's a long chain of dependencies. And um, one interesting thing with the tool chain now is that when you look in Visual Studio at your NuGet packages and it shows you which ones are vulnerable, it's now transitive. So it looks at vulnerabilities brought in through indirect references to other packages. So you will be a bit shocked when you first look at your projects now, and you will see that there's a lot of vulnerabilities here. And there are tools to help you understand if they are real vulnerabilities or not. But part of keeping up to date is also keeping up to date with not using vulnerable packages. And we also have clients where they've gotten stuck in this, I'm too far behind to get caught up. And then
Hmm.
there's a published attack, known that there's a vulnerability and they really need to fix it, but they can't because it means first we need to spend a big amount on getting everything up to date
Hmm.
because those old versions are no longer being patched.
Right. So Trailhead, we offer a service for that. Well, first of all, you mentioned security and scanning for vulnerabilities. We can help with that, but we can also help with what we call a tune-up. Can you talk a little bit about that?
Yeah, so that's a bit kind of in the vein of what I was talking about is kind of continuous improvement, and it's a version of that where you've shipped something. Maybe you're not doing active development because if you are, then you can just keep incorporating things as you go.
Hmm.
But maybe you want to make sure that um, you don't have vulnerabilities, and that if there is say a hotfix needed in production, that you are actually able to make that hotfix because your pipelines are still working and your build credentials haven't all expired. Or, if it's a mobile app, that there isn't some new requirement in Google or Apple that your app doesn't comply with, so now you can't deploy it
Hmm.
anymore. So the tune-up idea is it sounds a bit like a car tune-up, right? So we're taking it in for an oil change. But that's kind of the idea is you make sure all of the packages, the NuGet packages are up to date, but also, your NPM packages for your web app, your pipelines, your credentials, your tooling, everything is current, and then you run some vulnerability scans and make a decision whether there's anything that's important enough to actually fix in code or not. And we usually schedule that to be something that happens once a year or twice a year. For mobile apps, we kind of try and catch, the annual updates to operating system versions. Um, and then you could combine that too. So say you want to combine that tune up with, well, also we have this user request that we'd like to get done. So while you're in there getting everything running again, could you also do this? Which is also like taking your car in for your oil change, and they'll be like, oh yeah, your alternator belt needs replacing, and
Right.
oh, could we also add this thing?
Yeah, yeah. So switching subjects a little bit, you talked earlier about what a big focus .NET Aspire was, especially up front at this .NET Conf. And by the way, if people want to watch that, it's at dotnetconf.net. If they want to watch those videos, they're also on YouTube. But let's talk a little bit about Aspire. What are you seeing, and um, do you think it is correct what I'm hearing that this is the version of Aspire that is ready for prime time?
Yes, I think it's growing up. It started out, they kind of describe it sometimes as a tool for the developer inner loop. When you're actively developing something locally, and it's not a trivial thing. It has lots of moving parts. It's probably a distributed application. At the very least, it has a backend and a front end and a database, and maybe it has a Redis and a RabbitMQ, or it has different things. And it's not
Mm-hmm.
trivial to figure out the configuration, to see all the logs, to see where there are bottlenecks. You need to look in a lot of places to do that. And so it's kind of came out of that being a great dashboard and technology to integrate all of these things. But the recent changes have really made it a lot more interesting for kind of moving outside of your local development and more towards production. There's a lot of features that kind of are more polished that have been added, just practical, pragmatic things. For instance, uh, you know, you basically have an app host that is a project that you write code in that describes all of your components, gives them names that you can refer to them by. and says how they depend on each other. And those components can be other projects in your solution. They can also be containers, Docker images, things like Redis. Um, and they've added a lot of things around just managing these components that I think make it really practical. So you can, for instance, say, every time I stop and start my app while I'm debugging, I don't want all of these containers to go down and up again. Your RabbitMQ takes a while. Just leave it running. I'm just going to stop, my API and restart my API when I've written some more code.
Mm-hmm.
So you can have things kind of, they call them persistent resources that stay running. You can also say that, hey, this resource shouldn't really start until this resource has started. Like your database should probably be up before you launch your API.
Mm-hmm.
And it's not just it needs to be up, it needs to be up and healthy. So you can hook into health checks and say, well, okay, it's responding now to the health check. So it's ready to accept connections. So you can have your components now kind of start up in a coordinated way. Some of them stay running, some of them go down and come back up again. It all kind of reminds me a bit of Docker Compose. If you think of all of these services as containers, where some of them happen to be your app and some of them not. But Docker Compose also kind of describes how the services depend on each other and gives some names that you can reference to each other on a kind of a virtual network. And this is kind of like doing that in code and doing it with a fluent interface that we're used to for other .NET hosting tasks. So that kind of understanding of dependencies, it makes things really pragmatic. You can now stop and start them straight from the Aspire dashboard. You can actually add your own commands into the dashboard. So if you want to do something like reset all of your seed test data, you could add a command and wire that up so that you can, from the dashboard, say, okay, reseed the database with a fresh set of data. It supports Azure Functions now locally, and it spins up. You need to have this Azurite storage emulation when you run Azure Functions locally. But now it spins that up in a container, so you can see Azurite running and run your functions. And then they've also expanded the concept of how Aspire integrates with all these components. They talk in terms of integrations. So the host integrates with things like your project or a container in two ways. It has a host integration and a client integration. The host integration is in the host project, and kind of it's how you describe how it's going to kind of grab onto your different resources. And then the client integration lives inside of your project and kind of exposes things to the host. So it could be, say you're using a database or using a message bus, you would be adding those things into your services in your app startup. But now there's kind of extension methods on those that also kind of say expose that stuff to Aspire as well. And really the purpose of all of this is to do things like collect telemetry. So they use open telemetry to export all the data you need for structured logs and for telemetry for various events. So by instrumenting your projects with these client integrations, all of that stuff gets kind of extracted out and into the Aspire world. So they've got a really nice ecosystem that we can now extend. So there's a community toolkit where you can add, people can add their own integrations. So it's not just Aspire creating integrations for things. Everyone can now chip in and create integrations, which will really, I think, accelerate it. And then the final thing that I think really makes it more production ready is they've actually started thinking about deploying this now to production. So it's not just you're sitting in Visual Studio and doing this. The built-in kind of thing is you can deploy it to Azure Container Services and just kind of seamlessly lift it into Azure containers. But I think they've also put hooks in where you can notice kind of what environment am I deployed in and do things maybe differently in production. And the obvious extension is kind of going to Kubernetes maybe. It makes perfect sense. You can build the whole manifest out of the app host information. So I think we'll see more and more kind of production support for this. And maybe you don't use the the Aspire dashboard for looking at your metrics and traces and stuff. Maybe use Grafana or something else. But I think we'll see this maybe starting to replace App Insights and other things that we've had in the
Interesting.
past.
Okay. Yeah, it definitely sounds a lot more production ready than it was before. Things like the waiting for other services dependencies to start up before you start other ones
Yep.
would have been pretty hard to get anything real together without some of that stuff. So it sounds like it's rounded a corner.
Yeah,
There's some other
I think
stuff
so.
I know in ASP.NET that's kind of exciting and interesting. Can you talk a little bit about what else you see going on in ASP.NET that is exciting?
I've got a couple of favorites in there. One is the hybrid cache,
Mm.
and one is some of the JSON Open API stuff. Um, the hybrid cache is kind of interesting. So we've had the memory cache for a while, and it has its interface for storing things in a memory cache and setting how long before they expire and stuff. And then we've had the distributed cache, where you can externalize that. So you have a server farm or something, and you want to share some out of state process state, then you can put that in, say, Redis. And the distributed cache also has an abstract interface, so different things can plug into it. So it could be Redis, or it could be a database, or it could be something else. But its interface is not the same interface as the memory cache. So really, the way you use the memory cache is different from how you use the distributed cache. And the distributed cache is kind of primitive in that it doesn't really understand serialization. It lets you write strings and write byte arrays and read them back. And
Mm.
so it's up to you to figure out how you're going to serialize your objects. And a shout out here too is people have been using binary formatter to do that. Don't do that anymore. It's deprecated in .NET 9. It's dangerous. It's a vulnerability. But there are other serializers. You can do JSON serialization or data contract serialization and so on. But you had to roll your own. And another problem it has is what is called a stampede. So say you have a cache entry that's kind of expensive to synthesize, and it's time limited to maybe be stored for 10 minutes. And so you have 10 clients and they're all requesting this thing. They'll be getting it out of the cache. And then you get to this 10-minute marker, and now you get 5 requests for that thing. And the way it is now is all 5 of those are going to encounter that the cache entry is gone. And so you can get 5 sets of code resynthesizing the cache entries. And of course, they'll all get the right response back, but you're doing a lot of unnecessary work.
Mm-hmm.
And so typically you would create your own locking mechanism around your distributed cache to prevent that from happening, which is another nice feature in C#. There's a new lock object, which is more efficient. In the past, you could use a lock keyword with any object and use it as a lock. But if you use uppercase lock as a type for your lock, then it generates more efficient locking code.
Mm.
But you had these issues. So you've got your stampede, you've got your different interfaces from memory and distributed, you've got no serialization support. So what they did is they said, let's fix all of that with one class, which is the hybrid cache. And so the hybrid cache can store stuff in local memory, or it can store it in persistent memory. And it just depends when you set it up. If you add something that's distributed to it like Redis, then it will use that. And if you don't, it will use memory, but the API doesn't change.
Mm.
And it's set up in a way so that you specify basically a Lambda expression that is called when it needs to fetch the cache contents if there's a cache miss. And it manages the locking, so you don't get a
Mm.
stampede. So you just say, here, do this, call this when you need to fetch the object, and then the rest
Yeah,
is all managed.
very nice. Very
And
nice.
I think it's in preview, this one, but it's also back compatible with .NET 8, so you can actually use hybrid cache in earlier .NET versions. So that's
Nice.
definitely something I'm looking forward to using.
Yeah, and you mentioned there's a second one in ASP.NET.
Yeah, it's the changes to Open API. So typically you'll use something like Swagger to generate documentation for your minimal APIs or for your controllers. And as of .NET 9, you can still use Swagger and Swagger UI, but part of this whole thing with AOT support and not using reflection and trying to perform startup improvements is the .NET team decided they wanted to really provide a much better performing open API generation of documentation of APIs. So it works really the same way. You kind of add it to your pipeline, and it generates documentation for all of your API methods, and it follows the Open API standard that Swagger also used, and it relies on some new classes, JSON schema that can generate JSON schema from a JSON type, and it can do things like showing you nullability or type information that's helpful. Actually, what it doesn't have right now is it doesn't include XML comments that you put on your members or classes, but that is coming. Maybe a preview, maybe .NET 10, but that's kind of a little bit of a mission. But to address that, there's also a mechanism called transformations. So you can add in your own transformations on top of what gets generated to do things like adding in stuff from XML comments, or maybe adding in more detailed information about enum names versus enum values, or adding in information about validation rules for DTOs that you can get from your Fluent validation classes, that kind of thing. So it's missing a little bit, but it performs a lot better. And now you can add in a different UI if you want to actually see what's generated. So you can use this one called Scalar that I've looked at that looks really nice. It's a NuGet package. It will give you a Swagger UI-like UI with a light theme and a dark theme and other themes. It also has the ability to generate code snippets for your favorite language that's going to be calling the API. So it can give you examples of how to call each method. And you can set what's the default language. Maybe you're working with some React developers, so you want the examples to be ready for them to consume. So it kind of has some nice bells and whistles that Swagger UI doesn't have. So I'm going to look at starting to use that instead.
Yeah.
And then there's also the ability to do this at compile time. So you can generate your Swagger doc or your OpenAPI doc at compile time rather than at runtime. And you can actually then use that. You can either use that document and publish it, but you can also run like a linter on your API documentation output and check for things like, have I done all of the things that I want to do on all my API methods? Like, have I specified what kind of authorization is needed to call them?
Yeah, or the response codes or whatever.
Response codes is a good one. Yeah.
Nice. Okay. Well, there's so much in .NET 9, for a standard term support release. It's hard to even get through all of them. I know there's Maui and Blazor updates as well, but I want to really, before we wrap up, just focus on AI, which was kind of the second biggest thing
Yeah.
at .NET Conf
Yeah.
after Aspire. Can you tell me what you're most excited about with what's new in AI for .NET developers there?
Yeah, there's a few things that stand out, and I've been playing around with a couple of them in some customer projects just to see how they might pan out for some work we're doing next year. One of them is the Microsoft.extensions.ai namespace, which really what they've done is created abstractions for things that are common across different AI models or capabilities. So like a chat client or an iChat client, typically different AI services will have some kind of completion or streaming completion where you can get answers to questions. And so now there's an iChat client, and then you can configure that iChat client to use, say, OpenAI or Azure OpenAI or Olama, and which model to use within each of those. But your code can use the more abstract iChat client and the capabilities of iChat client, and you can swap out the underlying AI service or model with configuration, and try how well do they perform with different tasks. So it makes it really nice to write code that's not so tightly tied to a specific implementation, although they still do expose the underlying capabilities.
Mm-hmm.
There's also abstractions for things like embeddings, and that's where I've done some initial work. So we have a system where there's a list of medications that you can search, and they all have pretty technical names, and the user tries to type in something to search for, and they're going to spell it wrong, or they're going to get something part of that name wrong.
Mm-hmm.
And our client wants us to do kind of a fuzzy search. And we tried to use things like free text search and sounds like and different things to do it, but wasn't really happy with how that was working out. The embeddings and the vector search is really interesting because it can take. I took the whole list of medications that exists, and you can vectorize each of those kind of phrases or sets of words and give it kind of a coordinate in a space of like all of those words. And then you can store that in a vector database, or you can store it in memory. And so I took that whole set and I gave it to a Llama and I gave it to Azure OpenAI AI to compare. And then you take the user's input and then you vectorize that as well. And then you just ask, well, this vector, what is it closest to in this space of all of the vectors for all the medications? And by close, it's not like an exact match. It's like
Mm-hmm.
what concept really in this space is it most similar to, which is a way better way to do a search in this
Mm-hmm.
case. And they both performed pretty well. I think Azure OpenAI maybe was a little better at matching. But on the other hand, Olama, you can run your model locally and not have to pay for the tokens. So
Right.
the fact that you can interchangeably use those two for the same task is really interesting.
That's cool. So many great things and so little time to get through them all. Thanks for giving us kind of a quick overview. As you know, since I know you're a podcast listener, I like to ask all my guests a question at the end of every episode, which is basically what other topics should we be talking about, or who else should we be talking to on the podcast about making software projects more predictably successful?
Well, it's probably no surprise given the focus in .NET 9 on .NET Aspire. I think it kind of lines up quite well with the idea of making software kind of predictably successful. Is a lot of the things Aspire does are all about metrics and traces and allowing you to understand instrumentation and be able to really get to performance bottlenecks and issues early on and easily. So someone on the Aspire team, I think, would be a great person to talk to. And there's a couple that come to mind, but Maddie Montequilla has done a lot of content at .NET Conf, and it's always fun to interview one of the
Yeah.
strong women in tech. So
Yeah, that sounds like a great idea. I think it's very likely that we'll have some Aspire content at some point in the coming months.
sounds
Well,
like a good
John,
aspiration.
yeah, that's right. We're aspiring to cover that. Love it. John, thanks for your time today and for your expertise on .NET and all things software. Loved
Thanks for
having you.
having me.
Yeah. Bye-bye.
See you.
That's the end of this Blue Blazes podcast. If you're interested in hearing more conversations like this one with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.